Hello guys, I've come with complex numbers questions to find or proving and finding the values of x and y, or in other forms like x and y or a and b, their values. So I'll start with telling you some. We need to remind each other about the uh, properties of complex numbers, or we say rules of complex numbers. So complex numbers is a number which is written in form as a plus b I is the complex number. So there are few properties, or say rules, for complex numbers. Number one, if this is a complex number y, if you see this number i of I is same as you've seen the value of square root of -1 is equal to square root of -1. And second, you have si. If you have a squared, is just equal to -1. I squared is equal to -1. And then number 3, each complex number has its conjugate. So we say if you have a complex number of 2i, its conjugate is just equal to minus 2i. This is a complex number, and this is a conjugate. This is a complex number. So and sometimes you may be asked to, maybe in a question you find, if you say you find if s is equal to x plus yi, what is the s bar? So the s bar is just, they're asking the conjugate of s. That's the s bar. So the conjugate of s is x minus yi, like that. Yeah, so now let me show you the questions we are about to start solving. We have a few questions here. So we'll start with this one. These are the questions we are solving today. This one, and second we have this one. Fourth we have third, we have this one. This will be our last question. No, not our last question. This is our third question, and fourth question will be this one. Key question 3a. We'll be solving this one. All right, so let's begin. We start with this. So as you can see, find the values of a and b in each of the following. So a, b, c, d. We need to find the values of a and b. So we'll start. A is 3a plus 2i is equal to 12, open bracket, a plus b, close bracket, a close bracket, is equal to bi. So let's solve this one. So this is the question for number one. So as you can see this question, so so here we have, this is a real part and this is imaginary part, and here we don't have the real part here because this imaginary number here is multiplying with everything here, and this 12 here is multiplying with everything here. So this part we have the imaginary number. How can we show the imaginary part for this part? So I'll let this to be, this whole is to be a. So my so say this is my a plus I said this 12 open bracket a plus b is my a, so I'll put the imaginary there. So my real part will be a b, right? So my real part here, since we don't have, so meaning this b is just equal to 0. right? So let's just go back a bit. Let's just multiply this part. We expand this part. So when you multiply, you get a 12ai plus 12bi. So as you see, this is imaginary part, it's whole thing. So I'll write this one the way it is, plus. So here, since this is my imaginary part, meaning my my real part is 0. So I will, from here we need to equate the real part to the real part, the imaginary part to the imaginary part. So what we do here, since our imaginary part is this one and the real part is 0, so I'll say my 3a is equal to 0. So since my 3a is equal to 0, we divide both sides by 3, you get a 0. All right, so my a is 0. Now we come to this part. This part we are equating it to the imaginary part, to imaginary part. So I'm getting 12ai plus 12bi is equal to 2i. So where there is, since my a is 0, so where there is a, I'll put a 0 for simpler solvings. We don't have to waste much of time. So 2i. So when we multiply this here, it will give you a 0. So meaning we have a 12bi is equal to 2i. All right. So you divide both sides by 2. 12i and 12i. So I is going. So you simplify. You simplify here. What is the common factor of 2 and 12 is 2 itself. So you are just having your b to be equal to 1 over 6 and a be equal to a 0. Now we have solved this part, this question number a. Now we go to b. Our b is just equal to a plus bi is equal to 2. So a plus bi is equal to 2. So you need to show your imaginary part. So this is my real part. Now imaginary part is not there, so I just put a 2 a 0i. So from here I equate my imaginary part to imaginary part, real part to real part. So real value to real value, imaginary value to imaginary value. So my real value is equal to 2 and my imaginary part is equal to 0. So from here, this one we don't have a problem. This is your answer already here. So from this one you divide both sides by I since we need a b. So I divided by 0 is 0. I and I is going there. So b is equal to a 0. So as you can see, and in b we have a is equal to 2 and b is equal to 0. We go to question 3. We go to question 3. Not question 3, is question C. Question C is 4ab minus 3bi is equal to 4 plus. Yeah, so same thing. So here it is a question. So as I said before, like we equate a real part, imaginary part to imaginary part. So I'll have my 4a to be equal to 4. So we divide both sides by 4, which is a is equal to 1. Done there. This is too simple, guys. So just have to be, and I have my negative 3bi is equal to 12i. So I will divide same things. So I'll get 3 negative 3i divide by 3 minus 3i. Yeah. So this and this will go. I am having a b. A b 12i divided by negative 3i, negative 3i is equal to minus c. Right. Yeah, so 12i divided by negative 3i is just a 4, negative 4. So therefore we say a is equal to 1 and b is equal to negative 4. Fine, we go to the last question to this page here. Last question is a, so this is the last question. So this one too, you can just, if you want, so this is the imaginary part and this is the imaginary part, the real part, and this is the real part. So I'm equating from here. So I know my a is equal to 4, and this part I'll say 2a open bracket plus b close bracket I is equal to 3i. So minus, in fact there's a negative there, don't forget. So what you do is I'll get my 4 to play, I'll place it here. So I'm just having a 4 multiplied by 2 plus c b close bracket I minus is equal to minus 3i. 3i. So 4 times 10 is 8. So from there, I'm getting 8 plus b is equal to minus 3i. You multiply everything by the I. So I'm having my I, 8i plus bi is equal to minus 3i. Like terms, I'm having a bi is equal to this plus this is a negative minus 11i. Divide by both sides by I. So I'm getting my b to be minus 11 and a to be a 4. These are the answers. We go to the second question. This one now is a game. This one here we have finished, and we go to this part here. Here there's a big game. Excuse me. So here we are showing that, and we are solving first the expression, and express it in x plus iy. We express it as x plus iy from like z1 over z2 minus I to the power 4. So that's the question, where z1 is equal to 1 plus I and z2 is equal to minus 1 plus 2i, in case you can see, so you can write that. So we have to, then it says find z1 over z2 minus I to the power 4 and express your answer in the form of x plus iy, where x, y are the members of real number. And Roman numeral 2 is saying find a complex number z is equal to x plus iy, where x, y, and z are x, y are members of real numbers, such that z plus 1 over z is equal to 2i. And we have to deal with this one too. So let's go, we start our journey. So this is our question here. We need to solve this one and express it as x plus iy. Right, let's go. We do the calculations. So we have our z1 is 1 plus I over z2 is a minus 1 plus 2i minus I to the power 4. Now let's deal with this one. I'll do it from here. We know I squared is equal to -1, and imagine you have another I squared, you're multiplying I squared times I squared. So let's do this. I times I is equal to -1 times I is equal to -I times I. This one will be, because I times I, let's put this one here. So I times I itself is -1. So times negative here, you have a 1. So it's +1. Right, so +1, but so this is +1 here. Now, the +1, you get it here. It will give you, because we have an originally negative here. So positive times negative is a negative still. So I am having my equation here as plus I over -1, sorry, what? -1 plus 2I minus 1. So from here, let's just find the common denominator. That's the thing to do. So the denominator will be this. So -1 plus 2I. From here, this is our denominator. So this time in this one, we have our plus I minus this. In here we have a 1. So we just have the same this one. So it will be minus 1 plus C is a 1. It is multiplying plus 2I close bracket. So I need to multiply this part here, negative, with these guys in the brackets here. We need to multiply them. So do this. So I said we are multiplying that part in brackets. So as minus I, a plus I. So negative times negative, there it was positive, it will be positive minus 2I when you multiply that part over minus, not 2, minus 1 plus 2I. So here you add what is on top here. You have something which is liking. So this plus this one, 1 plus 1 is a 2. Plus I minus 2I is minus I over minus 1 plus 2I. So from here, I'm putting a dot there, meaning there is conjugation. We are rationalizing here the denominator. So rationalizing the denominator, you get the conjugate of the denominator. So the conjugate of denominator is -1 minus 2I, open bracket, over -1 minus 2I. This is your conjugate of your denominator. So just let me write it on top there. -2 minus I. Okay, I'm getting it. So 2 minus I minus, so we are multiplying this, -1 minus 2I close bracket, -1 minus 2I. So we are multiplying here. 2 times -1 is -2. 2 times -2I is -4I. -I minus -I times -1 is plus I. Then -I multiplied by 2I. So I times I is -1. negative 2 times negative 1 is positive 2. Positive 2 times negative 1 is minus 2. So here divide by this times this. So this one we can just multiply first and last. Like what I mean is first you forget and last, because this is a difference of 2 squares. So when you do like that, it's the same as you do the whole calculation, but because you get at the between here, you get something which will be cancelling. So there's no need like to waste time. Just do so. I'll do like this. 1 times negative 1 times negative 1 is positive 1. 2i times negative 2i. So negative 2i is it will be a minus 4. I times I mean 2 times negative 2 is minus 4. I times I is minus 1. So minus 1 times minus 4 is plus 4. So from here we are adding negative 2 times negative 4 plus and negative 4 plus I. So I'm getting negative 4 plus 3i over 5. So from here over 5 I can distribute this the 5 denominator here, so I can write it as 4 over 5 plus 3i over 5. So this is our so this question was what was the question? We were just okay. We are finding and expressing it as x plus iy. So this is x is the real part and the iy is the imaginary part. So in such a way we have shown our answer. So this is our imaginary part and this is our real part, hence solved. Now we go to Roman numeral 2. This one is there are some tricky things we have to do. So Roman numeral 2, it says our z is equal to x plus iy. So we are finding z plus half 1 over z is equal to 2i. So we are replacing this in a z. Sorry, you can't see. So we are replacing this in every z. So this is the question here. So let me rewrite it. So I'll rewrite it in this way: x plus iy plus 1 over x plus iy is equal to 2y. Right, from here, if you want, you can find the common denominator, or if you want, you can just multiply. You do this, then multiply with you multiply with this, both sides, this side and this side. You multiply with this, so write it as x plus iy. Yeah, it multiplies this one. So when it multiplies, meaning here it will cancel with this, and you remain with this times this plus. So just let's do the, because here you have a 1, so this times this plus a 1, and here this one to multiply with this, this to multiply with this. Right, this is going down. Let's find the common denominator. So common denominator is this. So put my x plus iy. So I'll have this in 1, we'll have same x plus iy close bracket multiplying by x plus iy close bracket plus this in this 1 times 1 is 1 is equal to right. So this is how it will look. So we can expand this part here. We can expand it. So let's do it on top there. So expanding that part, we have x squared, x times x is x squared, and x times iy is equal to is plus x iy xi plus x yi minus then x yi times yi is negative y squared plus 1, don't forget that one, over x plus iy, and here we have 2i. I don't know if you can see it, 2i here. So you cross multiply from here, you cross multiply, just have, and I cross multiply this part, I'll add what the numerator, the like terms, so 2x I x yi minus squared plus 1 is equal to, I'll multiply 2i multiplied by x multiplied by iy. So I'll have 2x 2i multiplied by minus iy. I'm having a minus 2y. All right. So from here, you will like terms. Do the like terms, real part, imaginary part, imaginary part. Let's sample them. So I have my x squared as my real part and minus y squared as a real part, and also that side I have minus y as a 2y, minus 2y as a real part, and so all those they are equating to, we are equating them to a 1, and the imaginary part I have 2xyi is equal to 2xi. So imaginary part. So I can start with this one is a symbol down here. So I'll divide both sides by 2xi, 2xi to remain with y. So my y will be equal to 1. So I use the y to find the value of x. So let us replace the y here in the top equation. Replace the y. So we replace the y. We have x squared minus 1 squared minus 2 divided by 1 is equal to 1. So this times this, so we have 1 plus 2, which 1 minus 1 minus 2, which is minus 3 is equal to 1. Like terms, I have x squared is equal to 1 plus 4, let me write it, plus 3 is equal to So I'm having x squared to be equal to a 4. Sure you can see this. Just cut here. So square root both sides. You have x is equal to plus or minus a 2. Therefore, the y is equal to 1 and x is equal to 2, or x is equal to negative 2. These are the answers for the question. It was yeah, we go to, don't know which question now we are solving. Oh, this one. We solve this one now. A b, it's a complex number. This De Morgan's law will do it. I think there's a video for this one, De Morgan's law. So no need of doing this. We are solving this one. So here we've been asked to show that this is equal to this. So let's go. When you've given this, you see it's a u bar. So u bar, it means the conjugate of u. So let's show that. Let's deal with it. This is the question. You have a u bar here. It means the conjugate of u. So let's go. Calculate this one. So I will replace my u conjugate is 2 minus 3i, close bracket, open. What is our w? Our w is y, is x plus c iy. So just let's multiply these ones over a 3 plus 2i. So we multiply this, what is on top here, I'm having 2 times x is 2x, 2 times iy is plus 2yi, and 3i times x is minus 3xi, 3i minus 3i multiplied by iy. I'm having a negative times negative positive plus 3y. A negative times negative, where is coming from? I'm getting this negative here, and the negative, when you multiply I times I, is negative 1. So that's the negative, it's getting positive. So I'm having that equation there over 3 plus 2i. So from here we can check what is like in here. Maybe we can add or subtract. As we can see, there's nothing we can do. So from here we conjugate, we rationalize the denominator. Let's watch here. So rationalizing the denominator, I am having a 2x plus, is it a plus? A 2x plus 2yi minus 3xi plus 3y. So I'm multiplying it by 3 plus 2i. And what is down here, 3 plus 2i, I'm also multiplying it with by 3 minus 2i. Same things. So when we multiply there, you're having a long equation. So 3 times 2x is 6x. 3 times 2yi is plus 6yi. 3 times minus 3xi is minus 9xi. 3 times 3y is plus 9y. Here we go. Go to the 2 multiplied by 2i multiplied by 2x is minus 2xi. Here minus, no, not 2x, is 4xi, and plus minus 2 4x 4yi. Now we have we have I, so I times I positive, so having a plus 4y, so 4y here, and I, this times this is plus 6x, not plus, negative negative, so have a minus 6x, and this times this we have a plus 6 plus 6y I. Let me go back, I will check this one. So I'll say 3 plus 3 multiplied by, yeah, it's plus 6y I, and here minus, something might be wrong here. Sorry, here is when you multiply a negative 2i might multiply by 3y is a minus 6y I, right? So from here, we don't have space, so you can let's reduce this from here. Maybe we can have the space, because I need to do this, the denominator by the denominator. So when we check here, we have a positive 6x and a negative 6x, so these are cancelling each other, and we have a positive 6yi and a minus 6yi, these are cancelling each other, and we check from here, we have a 4 minus 4xi, so these are adding up, these were adding up. Here we have what is adding up, 9 that was 9 plus 9y plus 4y and plus minus 9xi minus 4xi, so we are adding those, we are having 13y minus 13xi over, so the denominator, let's continue rationalizing the denominator. It was 3x plus 2i and 3x, not 3x, is 3 plus minus, now it's a conjugate, minus 2i. So you in a simple term of doing this, you just multiply the first with the first, last with the last, because there's a difference of it's the difference of two squares. So you have what is your first and last, that's your answers, you add those. So we multiply 3 times 3 is 9, so 13y minus 13xi, 3 times 3 is 9, 9, and 2i multiplied by negative 2i is a positive 4. So here we are adding, which we will have a 13 here as the denominator. So 13y minus 13xi over 13. So you can break this as 13y over 13 and 13xi minus 13xi minus over 13. So when you do that, you will see like 13 and 13 is cancelling. So you are having a y minus ix, which means, and when you go back there, you will see it was showing us to prove that, as you can see here, that this is equal to y minus ix. And as you can see, we have proven this one to be equal to u bar multiplied by w over v. So it's hence proven. All right, now we go to the last question. Excuse me. This one we are finding the values of x and y, and you can see we have the fraction, fraction to the left side and fraction to the right hand side. Now you can just pause the video and try this one as and compare with what we'll be doing together.